Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to another NL Math Man Math Help stream. Here, day 31. Day 31. We're holding it down, holding the fort. Um, yeah, so a little bit of a report from yesterday. I'm crazy, crazy busy these past, well, yesterday and today. So I didn't actually get a chance to go get those pictures of that Scotland hike that I promised, or that I alluded to more so than promised. So I will be back with those at another time. I haven't forgot about the Newfies of Loch Ness thing. I'm definitely going to show that off. That was a real cool little um, happenstance thing. Scotland was full of that actually. That same trip had like another instance too. Maybe I'll get into that at some time. Oh, on my Edinburgh, Scotland trip, I actually met a Newfoundlander in Edinburgh. The only other Newfie I met overseas, I met in Edinburgh in Scotland. Just, notice the Canadian flag on my backpack. Apparently, is also from St. John's. Boy, right out there in the out in the middle of the ocean. Anyway, I'm just rambling about other things that aren't even the stuff I've got on screen. Right here on screen now, we're back to the cabin again, the cabin. Right. This is a fire pit. Unfortunately, this no longer exists. This one has been lost to the sands of time, like as many things are. Um, you know, Last year we did some, or I mean, not us. The person contracted we paid to come in with the excavator did some landscaping out there, and the fire pit that myself and my father are sitting around in my mother's empty chair, which is directly behind my head because she took the picture. Um, yeah, that fire pit's not there anymore, but that represented a significant amount of work on my part. First, when we got the cabin, we dug out all around the sides of the building in order to make a trench, and we put down a metal skirting down below to help stop things like mice and squirrels. Right? As far as we can tell, we've stopped the mice and squirrels pretty well, but squirrels are wily little bastards, aren't they? They'll get into everything. They're like rats with bushy tails. Anyway, so we scooped out a lot of dirt around the cabin, and then we just had a big bunch of dirt. And I thought, well, what am I going to do? What are we going to do with that? So I took that down near the water's edge here, and I used it to make a sort of a landing kind of, because the water's edge was rather marshy and fairly low. So I put that in, and then I installed a fire pit, like with permanent stones in a sense. I mean, they were permanent until the excavator came through. Not permanent enough for the excavator, but yeah, I sort of wedged those into the ground and sort of made like a rudimentary little rock wall. And then you can see just the barest corner of the flames in this picture, licking out around the arm of Mom's chair, which is in the way. Right or there, just kind of just there we go, just next to my nose. Oh boy, I'm about to burn my nose. Right. So yeah, this is just I guess the cabin lot is all the same, in a relative way, but we're older. Um, yeah, the Vista is still there though. I have shown that one quite a lot, and that one does pop up on stream right behind me constantly, right? But yeah, that individual fire pit, the one that I put in there with some rudimentary landscaping, that one's gone, lost to the ages. Anyway, yeah, I have been a bit ridiculously busy today, so I haven't prepared a whole lot of banter. Not that my banter is ever prepared. This is like my break. This like first 5 to 8 minutes or so of stream. This is the break that I get every day between like 8:30 and 3:30 or so, 4:30 maybe. I don't know, 8:30 and 4, I guess. This is it, man. This is like this first 5 to 10 minutes of my stream where I just ramble about nonsense and talk about Garfield and hikes that I've been on. This is my break, right? It's mandated by my union of me, myself, and I. Anyway, today we are going to get into drawing straight line graphs. Right, that'll be the first thing that we're going to do. Esther, if you're watching right now, or if you are perhaps watching in the future, that is a topic that you from the review sheet that you just submitted. So I'm going to do a little bit on that. I believe I mentioned that this morning when I emailed you that I would cover those topics. I'm going to do inductive versus deductive sort of recap. That'll be real brief. Just a few short questions there. Then I've actually got another topic that's not on my list above that I was asked about specifically just a few minutes ago, which is sort of the formal proofs for triangles. There's not going to be a ton of that, but I am going to go over them. Now that one's for Betty Ann, but Nick, if you are watching as well, that is the unit that you are currently on. So perhaps I will link you that video as well. In the intro to geometry terms, I might or might not get to today. That's for Carly's next course, but she does have an exam sort of queued up, which I guess that'll be on Thursday for her. So that one's not super pressing to get to. The intro to geometry terms might have to wait until another day, depending on how long it takes to get through these other topics. Anyway, I'm going to jump over here now. Then I'm going to show the Math 3102A work that I'm going to start off with. So this is, oh, let me use my black pen. The black pen flows better. This is Math 3102A, Unit 3 review. There, like so. You just see. So I'm going to do now question, let's do this. This is question 1. All right. Yeah, I didn't really need to put it up on here though, did I? Because check this out. Check this out, Twitch chat. Look at this. Look at this technology, right? We're going back to it. Watch this. We're going to go to the greatest. Oh, yes, good morning or afternoon. Good afternoon, Esther. Glad you could join me. I'm going to go through these first 3 questions will be for your courses. But I'm going to switch on back now to the greatest image editing program that there has ever been. Clearly, it's Microsoft Paint, right? Why improve? Why improve on perfection is what I'm saying, right? Microsoft Paint's as good as it gets. I'm just going to go through and just real quickly show again about kind of what I mean when I say that we should label our axes and all that kind of stuff. I'm going to need a little bit more space on my canvas. So just really quick here. We know that from this list, right? Our heights on this side, well, the height is going to vary between, what is that? Between 156 and 155 and like 167. Okay. So I'm going to put height up here on the vertical axis. Now I don't really have enough room to write in height here. So I'm going to height, and that's in cm. Boy. Okay. I'm going to remove the brackets so that I've got enough space. Don't worry about that, right? That's, I mean, when you're handwriting it, you could wedge that in there somehow. So the height in centimeters is up along this side, right? So this is labeling of the axes. And down below here, what application is this you are using? Thanks, Albert Einstein. This is Microsoft Paint. Yes, the finest image editing software known to man only. None of this Photoshop or GIMP or View, although I do use View. I use that extensively. I'm using Paint just kind of for the novelty of it, and because it's awesome. Obviously, like it's Paint. How could it be any better? Down here is going to be weight in pounds. There, like so. Where'd my cursor go? There we go. Okay. So now I know that my height needs to go from about 155 to 167. So I got a load of blocks here. Let's have every block be, say, be 2. You know, I know this is going to get a little bit crammed in here if I have every block be 2, but let's just go with that, right? So if every block is 2, I need actually, this is going to take a little while, so I'm going to need a bit of space. So I'm going to need 154. I'm going to need a 156, 58, 160. I'm going to need a 162, a 164, and a Come on, Paint. What are you doing to me? Okay. Okay. My keyboard just stopped working all of a sudden there. That was disconcerting. Let's try this again. Let's try this again with the keyboard working this time. Okay. 154, 156. Here we go. 158, 160, 162, 164, 166, and 168. I know, it's a pain. This would be way faster if I was handwriting it, but I don't have grid paper, so I'm going to do this. Okay, so now what I'm going to do, using my, there, I'm going to put 154 right there. Oh, are you kidding me? Are you kidding me? It won't let me grab it. It's just letting me resize it. 150. Okay. Where the heck is making it transparent? Transparent selection. There we go. Better. 158. 160. Here we go. 162. We're getting there. We're getting there. 164. 166. And then 168. Hallelujah. Hallelujah. We got that step done. Good. Okay. And then for the pounds, let's say we've got to go from 135 on up to, say, 163. So I'm going to do those by fives. Say I do them by 5 each time. So I'm going to start with 135, then 140, then 145, then 150, 155, 160, and 165. That should get us to the end, right? It does. Okay, good. Okay, and I'm going to have, say, every 2 blocks be 5. So I'm going to have 1 block, 2 block. Those 2 blocks are 5 there, 135. These next 2 blocks are going to be 5. 140 right there. 145 down here. I could have just written it across, I guess. 150. Yep, got to do it manually. That way, you know, it takes longer. You get more content out of it, right? It's riveting. Absolutely riveting content. Somebody painstakingly moving some words around on MS Word. Okay, MS Paint. Now, there's another thing that I need to show you here. One thing that we have to do, you notice that here, right, this starts at 154 over here. This starts at 135 over here. So clearly they're not at the same point down here. If we skip some numbers, we're totally able to skip some numbers at the start, but we have to indicate it. We have to indicate it using sort of a jagged line. So I'm going to put a jagged line there and a bit of a jagged line there. I know it's a little bit scuffed because my freehand, you know, pencil drawing is not great, but we need the sort of jagged line in both those places to show that sort of it starts at 0 down here, then it's 0, skip a few, 135, 0, skip a few, 154, right? So that's basically what we're doing here. Then I'm going to go start plotting some points. So let me get a bit of a bigger thing. So I've got 135 and 157. So 135 and 157 would be there. We've got 150 and 160. So 150 and 160 will be there. 142, so that's going to be about here. 142 and 156 is going to be about there. So we've got 160 and 167. 160, 167 is, say, here. 155 and 162. 155, 162, right on that one. 63 and 64. 63 and 164 right there, say. And then 158 and 155. So 158 would be here. 155 would be here. Let's say it's that. Okay? And now, if I flick back over to my more normal looking page, let me go over here to my document display. Whoop, my keyboard is in the way. That's a Microsoft keyboard as well. That's I can't remember what it's called now. I can't remember what the brand is called. This is like the 3rd one of those I've had. It's very nice ergonomic keyboard. Let's see. Describe a trend in the data. Plot the table and draw a line of best fit. Yes, we do have to draw our line of best fit. Okay, that's what I was looking for. So let me go back over to Paint. Now I'm going to draw my line of best fit. So again, right, a line of best fit is a line that goes through the middle of these points as well as possible. It doesn't need to actually go to 0, right? I don't need to have 0, 0 in there. Although we do know that a person with a height of 0 inches would have a weight of 0 pounds. But, you know, maybe not the most relevant of data points, right? So I'm going to try to put it through the middle of these as best I can. This one here looks to be a bit of an outlier, but I'm going to let it pull it down a bit. So I'm going to say maybe like this. That looks about right. Hey, yeah, it's being pulled down a little bit by the outlier, but not much. So I'm going to say about that will be my line of best fit. Right? So this is just to show basically what you have to do for plotting here. But the main thing I'm going to look for is that you've got a label, a full label on the y-axis and on the x-axis. I'm going to look for your scale to be consistent. You know, here I've got 2 blocks for each. Here I've got 2 centimeters per block. Here I've got 2.5 pounds per block. But as long as it's consistent on the top, on the left and the bottom, we're fine. And then I've got my line of best fit drawn, and my points all plotted correctly. So that is going to give you the full marks on that sort of question. Right, so let me go back over to my document display. That was the part of question 1 that I really wanted to go over. So use the graph to determine the height. Esther, I think you were doing those ones really well, so I don't think I need to go over that very much. But I just wanted to show, again, just in some painstaking detail, what I'm looking for the marks for a graphing question. The next one I want to show is how to figure out basically if these things have a consistent rate of change or not. All right, so let me zoom in on the ones here in question 2. So it tells us to determine if the following table of values is a direct variation, partial variation, or neither. Explain how you know for each. Yes, now Esther, I do recall that you do know the qualifications, right? In order for something to be direct or partial variation, they both require a constant rate of change, right? And then those are the 2 real rules, right? So they both require a constant rate of change. Direct has the y-intercept equals to 0. Partial has the y-intercept does not equal 0. Okay, so here you're basically you have to figure out 2 different things. You have to figure out, is the rate of change constant? Then you have to figure out, is the y-intercept 0? Which for some of these we can just read off the graph, right? But say for this first one, for 2a, we've got our x's and our y's here like so. And then we've got 0, 1, 2, 3, and 4 over here on the x's. And the y's have 0, 3, 6, 9, and 12. Right? So to find our rate of change, we can find what we call the first order difference. Or we just find the difference between them. I'll call it its proper name, which is the first order difference. You don't really need to remember what it's called though, but you do need to remember why, how to find it and why. Basically, the reason we find this is we're just seeing how much it's changing by each time, right? So here, for these two, the difference is 3, right? From 0 to 3, it goes up by 3. From 3 to 6, it goes up by 3. 6 to 9, it goes up by 3. 9 to 12, it goes up by 3. And it's also worth checking. It's also worth checking to see over here on the x's, right? Because sometimes teachers, like, we're sneaky, like I've said a bunch of times. Maybe now down here, someone adds a point that's x is 6, and then y is 18. And you might look at that and think, well, that's a 6, and that means it's not a constant rate of change, right? But it's because they pulled a sneaky on you, and over here it was actually 2 difference on the x, whereas the rest of them will be 1. So it is worth checking to see the constant difference of the x's as well. Now, generally there won't be you know, this sort of nonsense, but it's totally within the realm of possibility. They could put that on there. But generally, what we'll have to do is just see these ones. But we know now that when x equals 0, y equals 0, and constant rate of change, therefore direct, right? This one is direct variation. The symbol of the three dots means therefore. And you did get this one right. You got a lot of these ones right. I'm not, again, right, I don't just pick out questions if someone gets them wrong. I pick them out if I think it's a good teachable moment based on the stuff that they've done. Okay, so I'm going to go on to, I'm going to do all four of these ones, I think. I'm going to go on to B over here. So for B, I have our X's and our Y's. So it's 0, 5, 10, 15, 20 on the X difference, and Y is 15, 30, 45, 50, and 65. Oh, no, that was actually my mistake, Esther. No, okay. Myself and the answer key were right. You were right for B. Yeah. I looked at the answer key and I said, hey, the answer key says it's constant. I glanced at it and I said, oh, that's constant. But it's not. No, you were right on that one. Okay, I'm gonna go back to your review sheet and give you an extra mark then. Because this one here doesn't have a constant rate of change on the Y's. Yeah. Yeah, the key was wrong. Boy, and me, because I believed the key, which I shouldn't. But the difference here is 15, right? The difference here is 15, but the difference here is only 5. And the difference here is 15. Okay, yeah, so good job. I'll go back and maybe I'll give you 2 extra marks for that one, just to make up for the fact that I incorrectly told you that you had that one wrong. Right? Because this one here does have a non-constant rate of change. Right, so well done. But we see here that it's not a constant rate of change because this now goes up by 5 for this one and then 15 here, right? The rate of change of the x's over here is constant. But that's not what we're concerned about. We're not concerned about really the rate of change on the x. What we're actually concerned about is this divide by that has to be constant. So if this was a 1 over here, like say if this was an 11 and then this was a 16, then this would be a 1 and then it would all actually work out, right? But it's not. So never you mind. I'm going to put this back to being the correct number so that when I send you the notes, it's actually the correct one. So that is a 15 there, and this is a 20 over here. But either way, not constant rate of change, therefore neither direct nor partial. All right, I'm going to make a note to myself. I'm 11. Oh, I'm 3102. Make a note to myself to change the key for that question. Okay, I'm going to go down to question C down here. Yeah, okay. Now this one here. Oh, now look at that. Look at that. That's another one that the person doing the key get. Now I don't want to throw other people under the bus too much here, right? I don't want to throw other people under the bus too much here, but the key was off for this one too. Wow. Okay. I gotta trust my students more, I guess, and less less the key and more the students. But great job with these ones, I gotta say, because the key again said this one was direct, but it's not. It's not direct, and the reason it's not direct is actually fairly tricky, right? Because the y's are constant. This is a 9. This is a 9. This is a 9, and this is a 9. But over here we've got this is a 4. This is a 4. This is a 4. But this is a 3. Right? And there's your problem. There's your problem there. Because what you've actually got to do, right, is kind of what you're doing is delta y divided by delta x, the same as you are the rest of the time, right? Change in the y divided by the change in the x. Okay? So here, you're changing y divided by the change in x. Here's 4 over 9. Here's 4 over 9. Here's 4 over 9. Or 9 over 4, sorry. 9 over 4, 9 over 4, 9 over 4, 9 over 3. Oh, well, that's different. See, now it is okay. So after the stream is done, I will send you. I've written a note to myself already. I will send you an updated grade on the review sheet. Now, of course, the review sheet is bonus marks, so you didn't lose marks for the review sheet anyway, but you're going to gain extra marks now because, yeah, again, when I glanced over it, and whoever wrote the key too, we both made the same mistake, and that we didn't notice down here. This guy was a 15. If this was a 16, you'd be good to go, right? It would be constant rate of change, but because it's 15, then it's not. Okay. Well, hey, some of the best teachable moments are when the teacher makes a mistake, right? You gotta make sure to see those. And then I wanted to do question 3 as well. I'll skip part B there. Now you asked about question 3 specifically. Question 3 was done correctly, right, on your worksheet there. But I will go over now just how to do question 3. I'll do that one here in green. So create a table of values using the equation y equals 3x plus 5. So all you've got to do, right, to make this table of values is we're just going to go y equals 3x plus 5. And they've already told us which values to plug into the table. Right? So this is x's and this is y's. This is -2, -1, 0, 1, and 2. So we can just plug those in for the x value. We're all human? Yes. Yes. Thanks. No, but that's really good. It's a good eye to see that that this one here was. I'm impressed by that part. That this one here was a 15. That one is this one up here. Yeah, I should not have made that mistake. I mean, I shouldn't have made this mistake either, seeing I'm the teacher. But this one here, part C, is a lot trickier because it's just that one difference, right? It's good. So y is equal to 3 times -2 plus 5. So y is equal to -6 plus 5, or y is equal to -1. Right? And now we can go through and we can figure out the rest of those guys. Y is equal to 3, -1 plus 5. Y is equal to -3 plus 5. Y is equal to 2. I think you're starting to see where I'm going to go with this, right? And guess what? It's going to go up by 3 each time. I know it's going to go up by 3 each time because 3 is the one added to the x. So I'm going to just take 3 times this number and add 5 is all I'm doing, right? 3 times 0 and add 5, well, it's 5. 3 times 1 and add 5, well, it's going to be 8. 3 times 2 and add 5, well, it's going to be 11. Right? Right. That's all you got to do for that one. Okay? Now, you did do that one correctly, but you asked about that one specifically yesterday. I'm not sure when you sent the email. I didn't get the email until like 6:15, right? So I wasn't, I was not still doing work by that point, at least, right? I was done before 6:15. Oh boy, my chroma key is not enjoying it when I lean back. Boy, I smell something cooking. Must be my lunch. Either that or I'm losing my mind. I put something in the slow cooker and forgot about it. Probably not, or maybe. Who knows? If you're losing your mind, would you know? Right? Like, I guess not. Anyway, go back over to the intro. Stream starts soon. Nope. So, inductive versus deductive reasoning recap. Yeah, let's do that one here now. So, that will be, let's see, this page over here. Zoom in a little bit. So, here we go. So, it's this question over this way. Number 7, I'm going to do first. So which of the following choices, if any, uses deductive reasoning to show that the sum of three even integers is even? Okay? So actually, I'll go to the working display so we can see it, so I can get a bit more space. So it can fit up there in the corner. Okay, so which one of these represents the sum of three even integers being even? Well, A shows an example of it, right? But it says uses deductive reasoning. Right? Deductive reasoning means it's going to be a proof, right? So we know that it can't be A because A is inductive reasoning. A is showing a pattern. For B is x plus y plus z equals 2 outside of x plus y plus z. Well, I mean, for one, it doesn't, right? X plus y plus z, where'd that 2 come from? The 2 is not even part of it. So this is not even a correct equation in the first place. But even if it was correct, x, y, and z, those could be even, those could be odd, right? So we know it's not going to be B. In C, then, well, does C pan out? We'll see. This is Math 2101A, Unit 1 recap. Okay. So then number 7, 2x plus 2y plus 2z. Well, we know those are all even numbers, right? Because they can be divided by 2, right? Like so. So then we know if we take this 2x plus 2y plus 2z, that's going to equal 2 outside of x plus y plus z. Which is divisible by 2 and therefore even. Right? That one's just a nice example of again some of the um, types of deductive reasoning that we have seen, I guess. Right? And there's two other questions on here that I would like to do. So let me just scroll on down. Yeah, here we go. So I'll go over to my document display so we can see it a bit bigger. The square of an even integer is added to the square of an odd integer. Now, I missed this level of math and everything makes sense. Then you abstract algebra and lambda calculus. That sounds fun. I yeah, I don't not sure about lambda calculus. I don't think I did much of that. I did a math minor as as prerequisites to physics courses actually. So yeah, my I did linear algebra, vector calculus, that sort of stuff, or lambda calculus. I guess you might mean a vector calculus. Hey, that's probably a different thing. I don't know. Most of my math experience after my undergrad has been teaching high school math. But yeah, welcome, Elf. Glad you could drop by. So let's see here. This is going to be question 11. I'll do this one in red. So the square of an even integer is added to the square of an odd integer, aka the fun math that I teach. Yeah, exactly. Right? It's the good stuff. I wish I got to do more probability though. I do probability is my favorite just because of all the games and stuff that you can use to help teach it. Right? Making math games is actually one of the best parts about teaching for sure. So the square of an even integer. Well, how can we represent that? Well, we know that 2x is an even integer, right? Because an even integer is an integer that can be divided by 2. So the square of an even integer is that, right? And then added to the square of an odd integer. Well, it's added to, and we know an odd integer is 2x plus 1, right? Or we could call it 2y plus 1. Actually, I will. I'll call it a different variable there because we don't actually know. We could use x there. Like if you used x on a test, I wouldn't penalize you at all for that. I'm going to use a different little variable though to make it clear that it could be any number and not necessarily the same number as that one, right? But it's going to be that squared. And then we're going to develop a conjecture whether the sum is odd or even. Provide evidence to support your conjecture. Now, for conjectures, you'll recall, that one is inductive reasoning, not deductive. So you could use a pattern. But Betty Ann, when you did this activity, right, you used deductive reasoning. So I want to show the example as deductive reasoning, which I think is a really, really great way of answering the question, right? Is to use this instead of a pattern. But one reason why it's only worth 2 marks is because they just kind of expected you to do a quick pattern and be done with it, right? But I will show the deductive way, which is like the way you completed it as well. So now I'm going to go through and I'm going to square both these guys. Now this one here is just one term. Squaring that is easy. It's going to be 4x squared, right? Now over here, 2y plus 1. I'm going to do that one, write that one out. You don't have to. You can skip straight to the answer for this. But I'm just going to write it out like this and multiply. So you see what's going on. Plus, so this is going to be a 4y squared plus, it's going to be a 2y for that, 2y from the other one, so it's going to be 4y and then plus 1. Right? And we know that cannot be even. All right. So, since this result cannot be evenly divided by 2, it must be odd, right? So it's because of this plus 1 down here, right? So even though now I used, we see that it's y's and x's. If this 1 wasn't here, obviously the rest of these could all be factored, you know, by 2, right? I could take a 2 outside. But I can't take a 2 outside, not evenly anyway, because of this plus 1. And since this plus 1 is here, we know that the answer has got to be odd. Okay, I think question 15 was the other one that I wanted to go over. Yes, I wanted to do part A and B of question 15 here. So let me jump back over to this scene and zoom in a touch. There we go. So prove using deductive reasoning each statement. The product of 2 odd numbers is an odd number. Now again, this one is asking for deductive reasoning. So here we actually have to use this sort of reasoning, right? 15a. Product of 2 odd numbers is an odd number. Well, again, right? So we have to write out an odd number. So 2x plus 1 is an odd number. And then say 2y plus 1 can be another odd number. Now, if you, when you did this one, I believe, did 2x plus 1 and 2x plus 3, I think. I can't remember what the issue was with this one. In general, we would use x and y here, or just any 2 different variables to show that it could be a totally different number, right? Because if I use 2x plus 1 and 2x plus 3, well, that's 2 consecutive odd numbers, right? Because if x was 8, it would be 17 and 19, right? But the way I've done it here, x can be any number, y can be any number. So these can be any 2 odd numbers. It's a small difference, but it is important. So I'm going to go through and multiply these guys out. I'm going to get 4xy for the first one, right? Then I'm going to do this, so that's going to be a plus 2x. Then it's going to be a plus 2y. Then it's going to be a plus 1, right? And since I can't factor out a 2, the answer is odd. So that's all I'm really looking for you to say there, right? Because you can't factor it out, it's going to be odd. And now for B, the sum of 4 consecutive integers is even. Now here we are dealing with 4 consecutive integers, right? So the sum of 4 consecutive integers, well, we've got x, and what are the 3? We would need only 3 numbers following x, right? 3. There we go. So it's going to be x plus 1, because that's the next consecutive integer, x plus 2 plus x plus 3, right? And this is 4, 1, 2, 3, 4 integers. I'm going to take those and add those guys together. So we've got 4 x's, so it's going to be a 4x. And it's going to be a 1, a 2, and a 3. It's going to be 6. So we've got 4x plus 6, which is the same as 2 outside of 2x plus 3. And since we can factor out a 2, the answer is even. There we go. Right? So that's all there is to getting those ones. So let's see. Oh, we're making good time. Maybe I will have time for the Math 2017 sort of terminology intro. But Betty Ann, so that was a little bit of a recap from your last unit, and now you had some questions about your next unit. Excuse me. So let's see. What you were looking at specifically, I believe. Yes, there was a specific question from the assignment 2 that you were looking at. So let me just, you know, riveting content where I just scroll on down through. Actually, I'll tell you what. I'll talk you through one of the examples from your text first. So I'm going to talk a little bit about this one, and then I'll do maybe I'll do that exact one off the assignment that you asked about, but then I'm going to do one off the review sheet as well, just to kind of show you what's going on here for these questions. Right now, the same as when Nick was doing this one briefly, I did explain that this is really the only unit where we're doing this kind of proofs. Number 4, yes, thank you. Yeah, I'll get to that one there now in a second. But this is the only unit where we really do this exact topic. So I'm not super concerned if you give the reasoning with the totally correct sort of phrasing, right? I'm more concerned that you are able to identify all the steps that it takes in order to get to the solution, right? Excuse me. But here you'll see that they say given that FG is parallel to HI and that triangle GE is similar, or sorry, GE is similar to EH, prove that triangle FGE is similar to triangle IHE. All right. So the things that we're told that were given at the start is that FG and HI are parallel. So we know those two, and we know that GE and EH are the same. Right? I don't know why they've got the similar to, because they're just line segments. I think that would just be equals, right? Wouldn't be similar to. Anyway, so angle F equals angle I, and we know that because they're alternate interior, right? So remember when we've got a pair of parallel lines and a single line that goes through them, we know that sort of this circle here, all the angles around there, are going to be the same as all the angles around this one down here, right? But alternate interior, we know that these two have got to be equal. And by the same token, we know that this one and this one have got to be equal. But we can say alternate interior for G and H as well, right? And angle FEG and HEI have to be the same because those are all opposite angles. So now we know that we have 2 reasons. They say angle side angle. We actually don't have angle side angle. I'm not sure what they mean there because we don't know that FG and HI are equal. We don't really have angle side angle. We have 3 angles, angle, 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 which tells us that they're similar. So maybe this is not the greatest of examples in the world. I'll tell you what. Let me just go on down, and I'll do the one on the assignment. That's an easier way of doing this. Here we go. So this is the one that we were looking at. So given that LM is parallel to JK, right? And given that angle LMJ is the same as angle JKM, prove that side JK is equal to side KM. Okay, so let me just sort of write out the things that we know on the paper here. So I'm going to draw out my diagram. So this is JK, and this is LM. Right. So given LM is parallel to JK, I have that written out there, and then LMJ is equal to J to KMJ. All right, so let me mark that off. Sometimes we use, by the same token, that here we use arrows, sort of pointing this way and pointing that way. For the angles, I'm going to use sort of like an arc, right? A little arc segment. So LMJ is this angle, so I'm going to mark that with a single sort of black arc there like that. That one is the same as KMJ. Oh, look at that. So those two are the same. Interesting. Okay. So now, what sort of statements can we make? So we need our statements and our reasons over here. So we can start off, you can always start these off by listing your given ones, right? So we know that LM, JK, and those should be line on the top, and that's given. And we know that angle LMJ equals angle KMJ, and that one's given, right? So then I know that, say, this is a parallel line here, and this is a parallel line here. So what do we know about the points that are around parallel lines? Well, we know that this section and this section are all going to be the same, aren't they? But we have a thing called alternate interior. Alternate interior angles are they make a sort of a Z shape, right? So if you have a Z shape where the top and the bottom are parallel, and the middle is just the one line, we know that the ones inside the Zs are going to be the same. So now I can say that angle LMJ equals angle MJK, and that's because of alternate interior angles are equal, or I'll just call it alternate interior, right? And then I can do the same thing for this one over here. I can say well, that wouldn't really be alternate interior, I suppose. That would be sort of like alternate exterior, right? Um, hmm. Hold on, just 1 second here. I want to. Does that make any sense to say? Okay. Sorry for the pause there. Yeah, I got my screens messed up here. Okay, here we go. Right. So we know that those are the same because of alternate interior. We can also say that. Well, the thing is, in order to know that this one and this one are the same, we would need to know that that one and that one are parallel, which we don't actually know right now. We can, though, get oh, but they would have to be. Yes, they would have to be. They would have to be because we know that these angles on them are the same, which means these two here are parallel. Right, right, right. So we can even say now that line LJ is parallel to line MK. Haha, right. We can say that. We can say that because sort of because we've got the same angles at the top and the bottom there, right? Okay, if LMJ equals KML, LMJ equals KML. Oh no, KML. Oh, we can say LJK equals LMK, right? Um, what we can actually say is that let's see, angle. Boy, I'm getting all befuddled with all these different angle notations there. LJM, LJM. We can say that equals angle JMK. That was by the transitive. right? And we know that side JM is the same in both because those are shared. And so what are we trying to prove? Prove that JK equals KM. Right. So we know that JK, side JK equals side KM because isosceles, or we can say the same angle, right? Because we know that if the angle here and the angle here are the same as each other, which we know that they are, then we know that this one equals that one. Okay, we actually don't need this part of the transitive property. No, right, okay. I was getting all, I wondered why the key was saying that. But again, this is just, I'm just really off my game today, apparently. Apparently, this is day 31. Day 31 is when it all starts to fizzle out, apparently. I just start, steam starts coming out of my ears and you know, math all drains out. Prove that JK is equal to KM. Well, we were actually finished that. We didn't even need to know this bit, right? That bit is true, but we didn't actually need to know that because all we needed to know was that this angle here and this angle here are equal, which we do know now. So we didn't even need this bit. Did not even need that in the slightest, right? The reason we didn't need that is because if this angle and this angle are the same, and this is a triangle, we know that this side and this side have to be equal because it's an isosceles triangle then. If the angles at the bottom of the sides are equal, then the sides have to be equal. All right. So we got there in the end. These are weird questions, right? But the important part to know is that if this angle and this angle are equal, we know that this is an isosceles triangle, which means this side and this side are the same because the angles at the bases of those sides are the same. So I was actually sort of, yeah, I was wondering why, like, what I was reading from what the key said and what I thought from looking at it didn't kind of mesh together. But it's because yes, because we don't actually need to know that part. Okay, tell you what, I'm gonna go to one that makes maybe a little bit more sense, and this is the review sheet. So you haven't seen this one yet, but you will in a bit. This is question 6 on the review sheet. Right now, this one here, I think maybe will be a little bit clearer, and I'll actually a little bit more similar to the kind of these questions that you are going to see when you do them on your test. You know, when you're an English teacher who did a science minor and got a math minor out of it because you couldn't get the science, and therefore are teaching English, math, and science in a program, I think I'm allowed to make an occasional mistake about an obscure topic like this. Anyway, um, I don't need to give my qualifications and say that I'm allowed to make a mistake. Everybody's allowed to make a mistake. So statement and then reason. I mean, I would definitely be making mistakes if I was teaching English on here. Absolutely, English is just a series of mistakes, right? A series of mistakes that you doggedly defend anyway, based on the best thing you can think of. I mean, it's kind of true, right? Like, it's all about arguing your case with some evidence as opposed to being objectively right or wrong. Anyway, you want to get into talking about objective truth on the internet, you never know who's going to show up. Sort of bro science philosophers have knocking down my door, right? People coming at me quoting Ben Shapiro and Jordan Peterson. Yeesh. Let's not speak that one into existence. Let's keep that keep that in the periphery of the mind. This is all about math, just and physics maybe occasionally, a little bit of biology. Who knows? Anyway, um, given A, B, and C, D are parallel, so we're told statement A, B is parallel to C, D. So we're given that. So AB parallel to CD. I'm going to go ahead and mark that one on my diagram, like so. That guy is given. And BC is parallel to AD. BC parallel to AD. Prove. What am I proving? I'm proving that AD equals CB. So I had to prove that AD equals CB. Well, that's not super hard because now we know now that we know that say that this angle here is going to equal this one here. And we know that because they're alternate interior, right? Because this is a parallel line and this is a parallel line. So here now we have our Z shape where the interior angles of the Z shape are our alternate interiors. So we know that angle ABD equals angle BDC. That's alternate interior, right? And we know then that, I'll do this in a different color, right? Just so we can see it on there. Normally what we would do is we would mark it in two arcs. We would have a single arc there, a double arc here, but I've got the luxury of using different colors here. So I'm going to say angle ADB equals angle DBC, and again it's alternate interior, right? Because now it's the Z from this line and this line going like so, right? And the interior ones on there are the same. And we also know that this is going to look a bit silly, but side BD equals side BD. Obviously it does, but that's a shared side, right? Because BD is in both triangles. And now we can say conclusively that the full triangle is actually equal, right? We can say that triangle ABD equals triangle BDC. And the reason here is because of angle side angle, right? Or ASA. Because we know this angle, this side, and this angle are the same as this angle, this side, and this angle. So if two triangles have two angles that are the same and one side that is the same in both, then they have to be exactly the same triangle. Because if two angles are the same, of course, three angles are the same, right? Because a triangle always adds to 180. And then, so that means we know that they are similar triangles. We also know that they're equal now because of angle side angle. So we can just say BC, side BC equals side AD, right? And we can say that these triangles are equal, say, right? You might not necessarily need to go down through it this much to say these, but what I'm looking for you to do is just show me through the steps that you're writing out that you understand how to find you understand the rules basically. You understand why these two triangles have to be this equal if this and this are parallel and then this and this are parallel. And we've just got the one bisector, right? But I mean, if you've got two pairs of parallel sides and you've got a line that goes from one corner to the other, we know that we have to be cutting it in half. Is basically all I'm getting at. Again, I never even did that topic in school, I've never done that topic ever, like until I was teaching it here. I managed to get through an entire like high school program in whatever, and then an entire minor in mathematics, which was like two third-year courses and like 5 or 6 second year and however many first year courses, and I never once had to do proofs like that. It's weird, right? How is that even possible? What do you know? What do you know? Okay, go back to my intro screen. So, intro to geometry terms. Yeah, it's 2 o'clock on the dot. So let's get to that. Let's get to that there today, because this is going to be relatively quick. So Carly, this will be where your stuff starts. So I'm just going to quickly go down through really all the questions on this page that we see over here to the side. It's not nearly as much as it looks like. So this is Math 2017 pre-test. And this is PMB page, what is this? 156. page 156. So then, question one, it says name each figure below as shown. What the hell? Oof, no, it's a G-rated stream. What the heckerino does that mean? I don't know. Does hell make it not G-rated in the States? I don't know. Thanks. Yes, you're very welcome, Betty Ann. Yeah, that's not a super important topic as far as I'm concerned. You're not going to see a ton about those. Again, it's just for this unit. That Math 2101A is it's a weird one. I got to tell you, it's sort of a standalone kind of course. But either way, the rules are important. The rules like alternate interior and all that kind of stuff, those are important to learn and you will see those again. But the formalized proofs like that, you're not going to. So here for this sort of question, like number one, we have to be able to tell if it's a ray, if it's a line segment, or if it's or if it's an angle or whatever. Zero cases again today? Oh, fantastic. Yeah, it's always good to hear. Yeah, really happy to hear more about that. And especially since yeah, just yesterday now we ratcheted back to level 4. You know, some more stuff is opening up. My only my sort of only oh not only but I guess my main concern about all of that is like I mean you look in Quebec, right, and it's nursing homes that where a lot of the cases are sort of congregating. Maybe congregating is the wrong word to use. A lot of the cases are spreading there, so it's a very vulnerable sort of situation for people. And so far in the province we've been able to keep COVID-19 away from any of those places and shut it down when it has come up. But you know, making sure that I guess people coming into the province are accounted for and we know sort of their testing history and all that. It's really important to help prevent situations similar to what they're having in Quebec. I do hope that they get through it though in La Belle Province. You know. Anyway, so Carly, for these questions here, we're looking to name each of these shapes, right? And for question one here, I know this is ray, and this is ray XY. And the reason I know it's ray XY is because a ray is like a one-sided line, right? Because the thing about a line in math is a line actually continues infinitely in two directions, right? So yeah, I'll put this over here. A line continues in two directions, and there's an arrow on both ends, right? Those arrows indicate that it continues. A ray Array continues in one direction, and I'm not nearly hip enough with pop music to make any sort of One Direction reference out of that. I'm sorry to the students that I taught in the UK 5 years ago. Sir does not remember your music tastes very well. And then a line segment. A line segment has two ends, so a line segment is a dot and a line like that, right? So that is just a little aside here. You will see that as you're going through. Those are the definitions, right? But number one is going to be ray XY, and we put the arrow over the Y because that's the direction that it continues in. So that's 1A. 1B is going to be angle, right? So it's an angle, and we put the symbol like that, and that's angle PQR or RQP. The important thing there is the middle. The middle term is the most important there, right? Because Q is the vertex has to be in the middle. For an angle, the vertex or the corner needs to be the middle letter. right? C is a line segment. It's line segment. What's that called? ST, and it's done with a line on the top with no arrow on it. And then D is going to be line. It's line MN, and it's done with a double-headed arrow on top of it, like so. Okay. Just to carry on, then I'll do question 2 in blue. Question 2 is going to be 2A is going to be ray. Sorry, not ray. Line segment JL, like so. B is going to be line AB, like so. C angle CDE, like that. And then D is ray, and that is GF, the arrow pointing toward the F, like so. Okay, that's all there is to these ones, right? You're just using sort of these definitions over here to answer these questions. For question 3, now use a ruler to compare the side lengths of each triangle. Tell whether it is a scalene, isosceles, or equilateral. Okay, so there we go, another definition for you. Equilateral, 3 equal sides. Isosceles, 2 equal sides. Scalene, 0 equal sides. Or 1 equal side, I guess. But like one, it's a case where 1 and 0 are equal, right? Like, you know, how many sides are equal to each other? 1? How is one side equal to another? Weird. Weird, right? Weird. Um 3A. I'm running out of things to talk about, obviously. I've gotta make, you know, minor things into a 30-second ramble. So this is isosceles. Oh, Isocceles. Yes. Celes. Wasn't Celes one of the characters in Final Fantasy VI, I think? Right? Like the blonde girl with the ability to like neutralize magic? Or there was Ceres with an R. I don't know. I can't remember. That was like 1995 or something. Um, No, to be honest, Twitch chat, I've played Final Fantasy VI since then. And I didn't even call it Final Fantasy VI at the time, right? Because I was a pleb. I called it Final Fantasy III, like, you know, a common mouth breathing console player. Don't want to inflame the old divides between PC and console here on the Twitch, right? That's the kind of I don't know, social divide that you don't want to be exacerbating on Twitch.tv. So for number 4, write R in each rectangle, S in each square, and X in each rhombus. So a rhombus is a four-sided figure with 4 equal sides. A square is a four-sided figure with 4 equal sides and 4 right angles. And a rectangle, well, I'll tell you what, for question four, you might there's a little bit more definitions than what I would explain over here, right? But say a rhombus. There we go. So that explains a little bit about question 4 here. Rhombus, 4 equal sides, square, 4 equal sides and 4 right angles, and a rectangle is 4 right angles. So what that means, and this is what you're going to see when you go through these questions, is that some of these are going to be more than one, right? Because this one here, well, is it a rectangle? Yeah, we know it's a rectangle. Um, is it a square? No. Is it a rhombus? No, right? Because the 4 sides are not equal. So then for B, well, is this a square? Well, it looks like a square, right? But are we done then? Well, it also fits the definition of a rhombus, doesn't it? 4 equal sides. It does. It does have 4 equal sides. And is it a rectangle? Yeah, of course it is. It's got 4 right angles. So part of what you're going to see when you go through this unit, and part of the main place that people end up losing marks in this unit, is because of not recognizing that, say, a square is also a rectangle, right? Or a square is also a parallelogram, right? Or a rectangle is also a parallelogram. The parallelogram is one that I didn't write out here because it's not one of the ones that you're talking about on here. But shapes can be more than one category at once, right? Then C is going to be, well, C is just a rhombus, right? We don't actually even know it's a rhombus. We're not even really given enough information to know, to tell, nor are we in the other two, actually. So never you mind. Those diagrams. Usually I sing Prism Math's praises, but not this time. This time the diagrams should have been better indicated. But for 5, then I'm going to say, well, parallel lines never cross. So parallel lines never cross, and intersecting lines will eventually cross if they're extended, right? So then for 5a, this one's parallel. Okay. 5b, then is going to be intersecting. And then 5c is also intersecting. Even though those two line segments that are drawn, those two pieces don't actually cross, if I extended them, or if anyone extended them, they would cross, right? So that's why those ones are still intersecting. Okay, so that's just a really quick look down through some of the terminology that you're going to be dealing with in this unit. So, Carly, I hope that is somewhat useful for you, but you will see it listed in fairly good detail on your Prism Math Blue pages in general. Okay, so yeah, that'll be everything that I wanted to get to today. Go back over here, one last look at the campfire down at the old, um, at the old fire pit. It's not there anymore. It was, plowed under, as they say, lost to the sands of time. But hey, still got the memories and the photographs, right? And hey, I'll just build a new one. I'm just gonna build a new one next time I'm out there this summer. I think that's gonna be maybe in the same spot, maybe someplace else. I'll figure out somewhere to do it. But I'll build another stone fire pit. Maybe I'll go whole hog and put like a barbecue in down there, the barbecue pit. That'd be fun, like an actual installed barbecue pit. I never got to my barbecuing the weekend, by the way. I thought I'd mention that at some point on stream, but Newfoundland, like the wind we get here is just so intense sometimes that it's really difficult to do outside charcoal barbecuing in high winds. My theory is that the reason why there's no like professional level barbecue restaurant in town in St. John's is because of the wind. Now, sometimes I say that and people are like, "Oh, Montana's is a barbecue restaurant." Montana's is a barbecue restaurant in the sense that like McDonald's is a steakhouse, right? Like maybe they serve some of the same things, but it's not, right? Montana's, it's heating up frozen entrees in an oven or a deep fryer, right? There ain't no slow cooked barbecue going on there, right? This is not a low and slow with lump hardwood in a pit. But anyway, my dream of opening the first barbecue restaurant in St. John's is probably not going to pan out because of the wind. But hey, we know what our climate is like. It's what makes us unique, apparently. Anyway, um, yeah, thanks for being here with me today, listening to my uh, unfocused rambling. I'm gonna go get back to work now. I guess my break's over. My hour and 20-minute break to yammer on stream is over. Now back to the work. Anyway, yeah, thanks for being here. Thanks for hanging out. Stay safe, and I hope to see you again tomorrow.